So we've been talking about right triangles, right triangle definitions of our trig functions. And so what I really want to do quickly is just mention some facts about right triangles, facts and definitions that are useful. So the first one is the Pythagorean theorem holds. Right, so the Pythagorean theorem holds, but only holds for right triangles, right? And so the Pythagorean theorem says that if you have the hypotenuse side C, and then the base A and the height B, then you can square the two smaller sides, add them up, and that has to be equal to the hypotenuse squared, right? So this is something that always holds for right triangles. One thing to note is that the hypotenuse is always by itself, right? So the hypotenuse has to be alone on one side of the equation, right? Whereas the two shorter sides are together on the other side. So that's important. That needs to be set up that way. The second thing to note, and this is for all triangles, this is true for all triangles, and that is that angles add to 180. So everyone probably already knows this, but angles add to 180 degrees, or if you're doing radians, then in radians they would add to pi radians, right? So yeah, so the angles will always add to 180 degrees, and this is true for any triangle, which means it's also true for right triangles. And then finally, I just want to define something that everyone should already know, but the definition, the perimeter. The perimeter is, of course, just the sum of all the side lengths. So the perimeter is the sum of all side lengths. And that is just a definition. It's a definition that will come up in the homework. So there is one thing to briefly note about the things I just brought up. So the Pythagorean theorem is an equation that involves all sides, right? So all sides are involved. And so if you're ever working with only sides and you need to find another side, well, this is what you would want to use, right? The Pythagorean theorem relates the sides. And in a similar manner, this fact here relates the angles, right? So the fact that all angles add to 180 or pi radians is a fact that relates all the angles. So if you're working with a bunch of angles and you need to find another angle, then this is the fact that you would use. So these are just two observations. So I want to very quickly do one of the homework problems. So this is the last homework problem in homework 3. And I will bring it up. So it says, this is a homework problem. We want to find the perimeter. Find the perimeter of a right triangle. Where the hypotenuse is 5. Hypotenuse is equal to 5. And it has a 36-degree angle. 36-degree. So this is what the homework problem says. And so obviously we would probably want to draw this. That would be a good first step. So we know it's a right triangle. So we draw our right triangle. And we know the hypotenuse is 5. Hypotenuse across from the right angle is 5. Right? And then we're given one of the angles, 36 degrees. So it doesn't actually matter if we put 36 here or here, because we could always flip the triangle. So we'll just put it down here at the base, which is what we kind of do in the typical setup. And what do we want? We want the perimeter. The perimeter is going to be the sum of all the sides, right? So 5 plus whatever's here and plus whatever's here. Well, we don't know what's here and here. So one thing we might want to do is label them. So I'll call this X, just kind of keeping with our coordinate system. We'll call this Y. And so the perimeter that we want, our solution is going to be 5 plus X plus Y, right? In principle, this is what our solution is. Problem is that we don't know what X and Y are. However, we can find out. So we know that we have an angle. We know that we have one side, right? So we have one angle, we have one side, and we have another side that we want. One unknown for now. So we'll focus on X. So we have an angle, a side, and we have an unknown. Well, this is two sides and an angle, so we can actually find these, right? So if we look at 36 degrees, we want to find a trig function that relates 36 degrees with the hypotenuse, right? That's our one side that we know. We know 5 is the hypotenuse. And the unknown. Well, which side is the unknown relative to 36 degrees? In this particular setup, X would be the adjacent side, right? So we want the angle, hypotenuse, and adjacent. So we gotta think, which trig function is this? Hypotenuse and adjacent. It's not that. It's not that. Hypotenuse, adjacent. So we want cosine. So we set up. Cosine of 36 degrees has to be adjacent over hypotenuse, X over 5. And then we want to know what X is. So we can solve for X. We multiply both sides by 5. And so we get 5 times cosine of 36 degrees is equal to X. And so this is part of what we need, right? It's the X coordinate. This, again, there's a specific angle here. So cosine of 36 is a specific number. We can use our calculator for that. So cosine of 36 degrees is 0.8 roughly. And then in my calculator, I am going to multiply that by 5. And so we get X is approximately 4.045. So this is part of our solution. We still need Y. So Y, of course, we can do the similar thing. So Y relative to 36, Y is the opposite side. And so we want to set up a trig equation, right? Except in this case, it's now opposite and hypotenuse. So for Y, our setup has to be opposite hypotenuse. That would be sine. Sine of 36 degrees is equal to Y over 5. Solve for Y. We want to get rid of this 5 on the bottom. So we multiply both sides by 5. Both sides by 5. 5's cancel. And so we get Y by itself is equal to 5 times sine 36 degrees. And again, number here, a specific number here means that this whole thing is a number. Sine of 36 degrees is 0.5877 times 5, and we get that this is approximately 2.9389, and that is why. Now there's one final thing that Wiley asked us to do. They ask us to round to 3 decimals. So we want to round the perimeter to 3 decimals. So we need to be careful here. We need to make sure that every part of our calculation involves more than 3 decimals. And then we round up at the very end. So the 4th decimal for the x is actually going to be a 0, which is not going to affect it in this case. And our y value, we want to make sure we use these for all these digits here, right? So our perimeter is 5 plus x. So 5 plus 4.0450. And then we add y, and that is plus 2.9389. So we get the perimeter. All the numbers that I have here is 11.9839. We want to go to 3 decimals. So we're rounding to 3. So we keep 3. We look at the 4th. And the 4th one is a 9 in this case. But if it's bigger than 5, bigger or equal to 5, then we round up, right? So 5 or more go up 1 floor. That's one of the sayings. So because this is a 9, we have to round that 3 up. And so our final Wiley approved answer is 11.984. And that is the perimeter of a triangle, even though we only had one side and one angle. So that's a homework question. So it might be wise to try that question now after you watch this video. And that is it for this.